Ladies and gentlemen, we are very honored to have with us today Dr. Rumi Naqvi, Director MERL, and Dr. Rumi Naqvi will be giving a talk to all of you here today about MERL's journey and about its role. So without much further ado, I would like to invite Dr. Rumi Naqvi to kindly come on the rostrum and address this gathering.
Hello, assalamu alaikum everybody. My name is Rumi. Anyway, my name is Rumi Naqvi. I work at Intel. I am a principal engineer there. And what we did over the last few years is we have established this microelectronics research lab. The idea was to establish it in many universities. We have started with the Osman Institute of Technology University, so our headquarters are there. And I will, So I will briefly, iski zarurat hai? Okay, so I'll just keep, my awaaz, I think I talk pretty loud, so if you can't hear me, let me know, right? Aap logon ko awaaz aa rahi hai in the back? Yes. So anyway, we started this microelectronics research lab about 2.5 years ago or 3 years ago in Osman Institute of Technology, and the idea was that I've been doing IC design for the last 30 years or system on chip design, right? So the idea was that when I was leaving Pakistan, I'll just give you a little bit of my personal history. When Pakistan leave kara, I graduated from NIT University of Technology. I was at the top of the class. I went to my father and he told me, look, मैं तुम्हारे ticket का इंतजाम तो कर सकता हूँ, लेकिन fees का नहीं कर सकता, right? You have to arrange your fees yourself. So I applied for a scholarship. The Aga Khan Foundation थी, उस ज़माने में एक BCCI FAST की foundation भी थी. So I had a lot of interviews. Anyway, BCCI Foundation gave me a scholarship for $10,000. That was a lot of money in 1989, right? So उन्होंने मुझे scholarship दे दी, right? So they asked me, okay, we are giving you $10,000 as a scholarship, you can take it and go. Lekin the problem is most of the people take the scholarship and go back and never come to Pakistan back, right? So how would you contribute back to Pakistan? So us waqt I told them, look, whatever I've learned, I learned through this journey, I'll come back and I will give back to Pakistan. So I went to US, I did my master's from Arizona State University, got a job at Intel, and then the life cycle started. And with time kept on passing, and there was this prick that was pricking my conscience continuously. I said something, I got this scholarship. Anyway, that was my basic motivation that kept on egging me that something has to be done. So I kept on coming back I came to NIT in 2006, then 10, 11. So we tried to do this lab concept, जो मैंने lab पे generate किया था, it was in 2006. But it never took off in NIT. But anyway, in 2018 or 19, we were able to start it in UIT, right? So that's where the whole journey kind of started, kind of a brief thing. So we'll go from there. Right now, the basic idea of this talk is I'm going to talk about IC design or integrated circuit designs, right? This is a very high level discussion. Obviously, you can ask me questions and I'll try to answer them, right? So the basic theme of the talk is that in the future, currently we see this dichotomy, right? People are thinking that if you're an electrical engineer, you're not a software engineer. Or if you are doing power, you're not a software engineer, right? What I'm trying to present right now is that there is this fusion of the technologies, and anything you do as an engineer, any field that you're working in, you would eventually have to know that particular field. You will have to be very good in software, absolutely. If you know something and you're not very good in software, then you will be pretty useless as an engineer, right? Because the idea is whatever things you're doing, whatever engineering analysis you're doing manually can all be automated, right? through software, and you can improve your efficiencies by a huge amount, right? So that's why I mean to say that there is an electrical engineer who knows no software means that he's not a very good electrical engineer, right? Similarly, a mechanical engineer. So that's one thing I want to. So the future is where whatever speciality you have, you have to think about software now like a basic skill. Just algebra, everybody needs to know algebra, right? X plus y is equal to 2. That equation everybody in engineering has to solve. Similarly, everybody in engineering would need to know Python, but have to know C++, have to know data structures. That's like algebra right now. And on top of it, obviously, they will have to know machine learning and deep learning, right? Because you will have to apply these things in whatever engineering space you are in, right? So in terms of the space we are talking about today is IC design or integrated circuit design, and the approach is it's a software-driven approach, and that's the future paradigm, right? So with that said, I mean overall our whole idea is to, and this is a quote from Google, that whenever we are building an IC, right, an integrated circuit, it will do some kind of a computation, and that computation needs to be done in hardware, but on top of it you need to, you need to build, I mean, if this is the hardware, right, you need to have compilers, you need to have operating systems, you need to have applications, right? Most of the people are operating at this layer, right? But there is no application without the hardware, right? So if you look at this pyramid, hardware is the base, but the rest of the pyramid, right? I mean, you should think about it as an inverted pyramid, right? The base is small, but the application domain is a very, very huge, right? I can run many softwares on a single computer, right? A computer where you can run or you can run PowerPoint, you can run Excel, you can run MATLAB. So that what tells you that if somebody is doing, even if you are designing hardware, right? Even then you need to understand the use cases, you need to know the operating system, you need to know the compilers, you need to know the applications, right? But somebody has to write the application on it, right? So that's why any complex hardware has to have certain features. It has to be secure, it has to have obviously security and safety and ease of use, and then what we are doing is even the process of designing the IC itself is all driven by software, right? We have EDA tools, you run simulations, these are being run through software. So everything is done through software. Right? I mean, that's the message I'm trying to communicate. Yeah, this is a guy from Google, he's a scientist, and he's predicting this machine learning and automation can make chip design much faster and cheaper in the next few years. Right? Right now, when I'm designing an SoC, we come up with the specification, then it takes anywhere from about a year to 2 years to design a system on chip, right? Because we are doing things manually. But the idea is Google has already done this, that if I use software-driven approach and then supplant it with machine learning, I can do it much faster. I can do it in 6 months, I can do it in 3 months, I can do it even in weeks, right? Just we are working on a concept in UIT, in SoC now, right? You can generate an SoC, in minutes it will create the RTL for you, and then you can run verification on it, right? So that is the idea that we're working on, right? Anyway, as I said before, Google has this paper that they did this research. They did a lot of studies of basically doing chip design. Chip design, one thing, these are all basically, I don't know how many people know this, but anyway, these are different kind of gates, AND gate, NOR gates, right? They are placing these gates in this area, and then they are showing you what is happening with this gate placement, right? You could do it through the normal automated flow or through machine learning, right? And then there are wires to connect the gates, right? The placement of the gates and the connection of the gates can be done through normal EDA tools or can be done through machine learning. What they showed that the normal process takes weeks or maybe months, but if you supplant it with machine learning, you give it to the computer, it keeps on trying many outcomes, learns from these outcomes, and then comes up with an improved placement, right? So there's a paper on it. Similarly, this is very interesting, right? Apple right now at their career page is looking for an analog mixed signal software engineer. This is like an oxymoron. Analog mixed signal is completely away from software, right? Analog mixed signal means somebody is designing an op-amp, they're trying to look at a small signal behavior. Usually, when I learned analog signal, and I don't know any software, by the way, just say that, right? So I could never have dreamt that I would have to know software, right? But now, today, Apple is saying that I need an analog mixed signal engineer, but he has to be a software engineer. So there is a fusion of these two technologies happening. This is the reason I put this apart, and I'm sure people are appreciating it. This is completely far away from software, right? You're talking about circuits, you're talking about currents and voltages, you're designing an amplifier. You have nothing to do with software. When I was doing analog mixed signal, I don't know what, 20 years ago, when I was learning it from Stanford, I took the class, nothing, we didn't talk about software at all. It was all done by hand, and the guy who taught me is Bruce Cooley. I mean, he's 85, 90 years old right now. I mean, most of the people who learned analog are his students. There was no discussion of software. He said, no, you just do everything manually. We were designing the circuit by hand. Now Apple is asking for that. Similarly, the other thing that is happening at Intel, where I work, is that Intel has opened a $1 billion fund for RISC-V, right? RISC-V is an open source ISA, instruction set architecture, right? Which is a language between the hardware and the software, right? So again, this is focused on software. Because once you design, the problem with RISC-V is we are designing ICs on it, but जो मैं stack I showed you before, once you have the hardware, you need to build the full software stack on top of it. You need a lot of people for that. You need to build the compilers, the operating systems, you need to build the applications, you need to transfer everything over. So again, the message is the same here, that you need to know software. If you are working in RISC-V, you need to know architecture, you need to IC design, but you need to know the software also. Right? That's the other thing. I think I should walk through this quickly now. Kitna time kitna hai? Time hai? Okay. So I think the message is again and again the same, right? Okay, again, once you design a RISC-V processor, right, the processor is useless. Agar mere paas ek processor par ho, I cannot do anything with it unless I have the compiler, then the operating system, right? So you have to do this whole tool chain optimization. Again, what we are suggesting here is that you will, basically the idea is that electrical engineering, right, because computer science eventually never existed. हमारा जो batch था 83-84 का at NED, right, उससे पहले NED में खाली electrical engineering होती थी. There was no computer science. That's the first time computer science was introduced. So one can think about it. Computer science is basic. Electrical engineering is a parent of computer science, right? Computer science was born out of electrical engineering. लेकिन हुआ क्या in the end? Computer science has now taken kind of over the whole realm. So what we are proposing now is that you have a program where computer science and electrical engineering are fused together. Everybody that is doing electrical engineering will have to do computer science with them also. Some basic concepts of computer science, right? This right? We already talked about it. Design and analysis of algorithms, artificial intelligence, compiler construction, right? This is kind of a basic course outline, right? An example of a course outline. This doesn't have to be followed exactly, right? But this shows that this is BS in computer science. I can call it BS in computer science and electrical engineering, right? Now that distinction between electrical engineering and computer science has to be merged. All right. So I think these are different things. The idea here is, look, there is a revolution coming, right, in the semiconductor technology. This was the industry is about $500 billion. Pakistan ke share jo hai is about zero, right? $500 billion. Does anybody know कि IMF से हम लोग कितने billion dollars लेने गए? किसी को पता है? तो पाकिस्तान के 6. Anybody else? $2 billion. तो हम IMF से $2 billion लेने गए और हम उनसे भीख मांगे for $2 billion. The semiconductor industry today, the total industry is how much? $500 billion today. In the next 10 years, by 2030, जब आप लोग इंशाल्लाह ताला जवान और ग्रो कर चुके होंगे, it will be $1 trillion, right? So $2 billion, $1 trillion के कितना percent होगा? Can computer somebody do the computation? $1 trillion is 1,000 billion dollars, right? उसमें से पाकिस्तान को $2 billion चाहिए. और आप भीख मांगे जा रहे हैं. We are being called beggars because of that. So look, this is in our hands. This is in your hands. And our hands and the hands of the faculty here right? $2 billion कितना होगा percentage out of the 1,000? कोई calculate करके बता सकते हैं कुछ? 2 over 1,000? 0.2%, right? So it's 0.2%. तो अगर हमें 0.2% of the market मिल गई, ऐसे semiconductor industry की तो at least IMF पे जाने की जरूरत नहीं पड़ेगी. So this is it. I mean, that's the message overall. This is a revolution happening. और ये जो there's this concept के artificial intelligence and क्योंकि artificial intelligence is like एक होता है ना, एक भेड़ चाल हो गया. Everybody wants to do machine learning right now, right? तो उन्होंने कहा right, but there is again to explain it. Chip design will be completely overwhelmed, जैसे कि आपने Google के scientists by artificial learning, right? तो हम जो chip design कर रहे हैं उसमें artificial learning इस्तेमाल कर रहे हैं और करेंगे और more and more करेंगे, right? So the people who will do chip design will be very good, will know artificial intelligence or machine learning at a very good level also. So I want to remove this misconception, right? और मैं तो I'm going further ahead. I'm saying that whatever you are doing, you will have to know software and you will have to know machine learning. Now there are 3 sets of skills. एक तो कोई एरिया आपने चूज किया, कोई आपको पसंद है, कोई आपका पैशन है किसी चीज के बारे में. You are learning that somebody likes power, they are doing power. But with power, they'll have to know software, and with software, they'll have to know machine learning. Because these 3 things together will make you a much more efficient person. And I think this is about it. There are a lot of opportunities. So जो हमारी lab है, microelectronics research lab, it's not only for electrical engineers, right? I think that's the method. Actually, predominantly it is for electrical engineers. But अगर मैं इसको distribute करना चाहूँ तो at the worst case scenario it's 50-50. बल्कि I would say 30 electrical engineers, 70% computer scientists, right? That's the distribution we're getting. Because जितने काम मैं कर रहा हूँ, I need to automate all the work that can be done, right? क्योंकि for example, अगर मैं एक chip design करने में मुझे 2 साल लग रहे हैं, right? A chip is basically a model किसी चीज़ का बनेगी. लेकिन if I can create that model, एक के बजाय मैं 1 million models create कर लूँ, right? Each model will be a data set. फिर मैं उन models से learn करके I can continuously keep on manufacturing new chips within days, within weeks, right? That's what we will do. इस तरह हम पूरी दुनिया को beat कर सकते हैं. We can beat people by not doing what they are doing today, but do what they are thinking about doing in the future, right? That's the idea. Okay. Anyway, I think that's all it is. Our call for collaboration is look, we are established at UIT or at Swan Institute or DSU maybe. So we started together actually to come back to the history, right? MERL ने जो start किया था, we started at UIT and DHA SOFA. SOFA में थोड़ा सा slow down हो गया था हमारा, and UIT obviously continue working very hard. इन लोगों ने बहुत मेहनत की, right? Hamza is an exception क्योंकि Hamza was in SOFA but he was working with us, and we call it the one-man army with that side, right? कि तो हमने यहाँ इतनी प्रोग्रेस नहीं कर सके, लेकिन अभी इस वक्त पूरे पाकिस्तान में भी रेवोल्यूशन आ चुका है. आपको पता ही होगा, यू आर हियरिंग न्यूज़ के नस्ट वाले कर रहे हैं. So this is a very promising and exciting field. I would invite everybody to join it and ask any questions. I think this is pretty much the presentation, right? Any questions or? Yeah.
Sir, can you explain, because AI requires data?
Yes.
So what would be data in this terms?
Oh, very good question. When he explained that, this is a very good question, right? Okay, data, there are two, AI and you must know that AI and data, there is 2 kinds of data. There is structured data and unstructured data, right? Let's say if you have an electrical vehicle, currently, let's talk about electrical vehicles, right? Because electrical vehicles right now, the vehicles, and so if you look at a current vehicle, so mostly are mechanically oriented, उसमें 2 sensors होंगे, right? Maybe current vehicles में. Later जो आगे 5 sensors होंगे, लेकिन अब जो लेट जैसे टेस्ला है उसमें I think they have 40 sensors, right? Or more than that. I'm just throwing out a number, don't quote me on it. But they have many sensors, right? All these sensors are getting inputs, which is generating data. This is all structured data. A lot of it is all visual data, right? Because they are doing visual image recognition of the different objects, और फिर उसको इस्तेमाल करते हैं to construct the image of the surrounding, and then they navigate the car, right? So that's a fusion of electrical engineering and computer science, right? The control of the car is done by the electrical engineers. There are chips, all the image sensing, all the sensors are all electrical engineering. Then there is a software algorithm running on top of it to do all that. Now coming back to your question, जैसे ये Google ने कहा था, right? Here what they did is, I mean, basically these blocks, जैसे मैं कह रहा था, these are placements, right? So this is one set of placements. So एक P1 will be one placement, that will be one set of data. Then you will have, let's say you place this, right, this number of, आप समझ लें कि let's make it very simple example कि आपके पास 100 gates थे, right? अब 100 gates को इस space में, if you do a permutation, you can place it millions of ways, right? right? तो हम ये करेंगे कि we'll place it, let's say 100 times, create a data set and learn from data set. But every time I make a placement, right, then I will do a routing, the connection between that, and then I will look at what the results are in terms of the delay through it or the frequency that this chip is achieving, right? So एक data set हो गया, I placed it, and इस तरह पूरा एक data set create कर लेंगे. अच्छा मसला इस वक्त क्या है कि यार ये चीज़ मैं करता हूँ और वजी भी कर रहे हैं करते हैं, इसको अगर हम नॉर्मल EDA टूल से रन करें तो हमें छोटी सी चिप में हमें 2-3 दिन लग जाते हैं, और बड़ी चिप्स होती हैं तो एक हफ्ता लगता है just to get one set of data, right? तो अगर मैंने 100 डेटा खरीदने तो 100 हफ्ते हो गए, right? So this all can be automated if I run it in parallel, generate all the data set and learn from the data set and optimize okay, what frequency I want to hit with this processor, what power I want to hit, right? What area I want to hit, right? This area will be this box where this placement is done can be reduced also, right? That's how you have to generate the data set and then learn from the data set to create a model to improve the outcome, right? Which is in general applicable to anything, right? I mean the difference between AI or you are the expert, but anyway, AI में क्या है कि you get normal coding में क्या होता है कि you have a set of rules, right? And you create a code to follow the set of rules to create an outcome. AI में you reverse the whole thing, right? You learn from the outcomes, you learn from the answer to create a model, right? To create the set of the rules, basically, right? That's what training is, right? Basically, you know, yeah, this is the answer, this is the image I want to recognize. I want to recognize the image of a cat, right? So I will give it many different cats and I learn from it, and next time the model is trained, and then I can recognize the cat, right? So that's the same thing we are doing here, right? We will do a lot of different permutations of the chip, learn from that, and then we are able to create a much more optimum, faster chip, right? That's the idea. Does that answer the question?
Sir, I have one question. What I'm seeing right now is, especially from this perspective, people, software side, because of the software side, students are dropping or they are not choosing the field of electronics or electrical engineering. So what do you think about it? They got inspired with the front-end development of AI and data science, and they forget about the studying the electrical and electronics. They totally switch the field. So we are always struggling with the good number of students in the electrical and electronics. So what do you think is your development अभी आई है, जो revolution आई है अपनी world, we are unable to balance it. हमारे साथ अच्छा range है, ज़्यादातर जो students होते हैं, they are, for example, I give you an example. Institute में 200 to 300 applications are coming for CS.
Yes.
And only like 10 to 20 or 30 applications are coming to electrical. And even if someone is choosing this thing, they feel, the students, they start feeling that they have chosen a wrong field. So what do you think if the good raw material is not coming, so we are going to lose this revolution, and we are already late like 5 years or so.
Yes.
So we can do something.
Yes. I think so. This is a fundamental problem, right? This is a push-pull model, right? A student is looking at the pull model, right? The market has a pull. Currently, in the market, there is a pull for software engineers. You can go out, learn software, get a pay for, I don't know, whatever the pay is. Let's say 1 lakh rupees, as just said, right? So obviously, as a student, I'll come in and say, why do I learn electrical engineering and then go out and get 50,000 rupees? I can spend my time. So that's the natural. This is a push-pull model that fundamentally we cannot change. But the thing that is happening right now in Pakistan is, right, I mean, there are external semiconductor companies, right? जैसे कि नवीद ने बात की, नवीद शेरवानी के, look, if you get trained in IC design right now, we can hire you. जैसे वो NUST का MS program है, it is sponsored by GSME. Whoever goes through that program, they will be guaranteed a job. Sohail from Big Semiconductor is asking me every day, do you have any person who knows Verilog system, Verilog, who knows RTL design, who knows IC design? I can hire them. I will interview them and hire them. So ये push-pull model की dynamics जो है change करिए. There's a lot of pull right now for IC designers, right? अब एक चीज़ everybody should understand कि software में तो बहुत सारे लोग हैं, there are a lot of players, so it's a many thing, right? क्योंकि pull भी बहुत है और push भी बहुत है. लेकिन इस वक्त hardware में या electrical IC design में pull तो थोड़ा create हो रहा है, लेकिन push अभी कम है, right? और ये it's like a linkage. It's a feedback loop. It's a positive feedback loop. जैसे जैसे pull create होगा वैसे वैसे push बढ़ेगा, और जैसे जैसे push बढ़ेगा वैसे pull ज़्यादा होगा. So there is no way to solve this. But I think right now we are solving it, right? We have companies who are actively seeking. Actually, there was another company who was saying, look, I need 400 engineers. Do you guys have them? Right? Every day I can get a project. Right? People are asking, okay, look, can you hire 40 engineers? Because even in India right now, there is a saturation in this field, right? Because there are so many companies there, they cannot find talent, or they are switching. So that dynamic is changing, और इसमें there is no good way to break this loop, right? This is the opportunity, right? क्योंकि इसमें दो चीजें हो गई, एक तो ये open source हो गई, चीजें हो गई, open source hardware, open source RISC file ISA. So this is the time to break it. और ये एक दिन का revolution है, it's going to take 10 years. So people who start today will see it, right? क्योंकि और दूसरी चीज़ ये है कि coming in IC design is a little bit more difficult, right? Software तो मैं I'm not minimizing software, लेकिन software तो ये है कि मैंने Python के क्या lectures देखे YouTube पे काफ़ी effort किया, I know Python, right? चल 6 महीने में I will do software, but 6 महीने में IC design सीखना मुश्किल है, right? और IC design में जो my hope is कि the base will explode, the opportunities to monetize your skills will explode, right? क्योंकि पूरी दुनिया में there is a dearth of talent right now, right? And everybody is looking for people who know IC design and software and machine learning, right? So that's the thing, right? Any other questions?
The question is, please
Do ask. Yep.
स्कोप के हवाले से, कैरियर के हवाले से, IC
हाँ,
डिजाइन
कैरियर।
कैरियर कैसे परस्यू करना है, उसके हवाले से. If you got any question, podium is open.
Then no question is a bad question, right? Every question is a good
तो
question.
ये वक्त दोबारा नहीं आएगा, डॉक्टर बार नहीं आएंगे, तो आपको कोई भी आपके जहन में सवाल, इलेक्ट्रॉनिक्स में स्कोप कहाँ पर जा रहा है, कि मैं ये FIP कर रहा हूँ, इलेक्ट्रॉनिक्स वाले पास आउट से जो इलेक्ट्रॉनिक्स को चूज करना चाह रहे हैं, हम ये FIP करना चाह रहे हैं, तो किस तरह से सवाल मत कीजिए. ये बात मैडम ने अपना नाम सेमेस्टर
मेरा नाम फराह कलम है और मैं सेमेस्टर 8 से हूँ और मैं पावर में हूँ, पावर मेजर इलेक्ट्रिकल इंजीनियरिंग. मुझे आईसीस के बारे में पता है बेसिक इन्फॉर्मेशन, बट बहुत डीप में नहीं पता. सो सिंस MERL आईसीस पर काम कर रहा है, तो अभी उनके टॉप में कौन कौन से रिसर्च बेस्ड वो है, मतलब आईसी कौन सी बना रहे हैं वो, किस तरह की,
मतलब for किस एप्लीकेशन बना रहे हैं, right? इस वक्त तो वी आर लुकिंग एट IoT एप्लीकेशन बेसिकली, जो हमने एक कोड नेम है प्रोसेसर जिसमें हम लोग काम कर रहे हैं UIT में, विच इज आज़ादी SOC, राइट? इट्स एन IoT डोमेन SOC, राइट? इट्स अ बेसिक SOC, राइट? सो वी आर जस्ट स्टार्टिंग विद इट. सो IoT तो आपको पता है, फॉर एग्जांपल इट कैन बी यूज्ड इन पावर आल्सो टू सेंस समथिंग, लाइक सेंस अ करंट और सेंस अ वोल्टेज, टू सी कि यार ये चीज़ ट्रिप कर गई कि नहीं ट्रिप की है. सो इट्स अ जेनेरिक SOC इन द एम्बेडेड डोमेन, करेक्ट? दैट्स द बेसिक. लेकिन inshallah the goal is to move to the application domain, right? So we will keep on continuing, right? So IoT is the lowest domain or the most compute unintensive domain, right? उसके बाद the next is to get to the application domain, where you can design a RISC-V processor for your laptops and then keep on moving up the chain for your phones and so on and so forth, right?
थोड़ा सा एक मशवरा बच्चों के लिए कि FIP अगर इस फील्ड में परस्यू करना है, FIP के कुछ छोटे छोटे पार्ट्स हों जो कि FIP बन जाएं, and they could lead them towards working in MPW-6
Yes, multi-project effort, right? तो मतलब FIP के तो बहुत सारे आइडियाज़ हैं हमारे पास. हमने एक पूरी लिस्ट ऑफ आइडियाज़ बनाई हुई है दैट वी कैन फ्लोट एंड वी कैन लुक एट इट. मोस्ट ऑफ देम आर रिलेटेड टू IC डिज़ाइन और ऑटोमेशन, राइट? दे आर कम्प्लीटली कि हम IC डिज़ाइन में कोई प्रोसेस कर रहे हैं, यू कैन ऑटोमेट इट. मिसाल के तौर पर राइट नाउ ये जो बात कर रहे थे, राइट, ये जो गूगल ने पूरा पेपर पढ़ा है, वी आर लुकिंग फॉर पीपल हु अंडरस्टैंड APR, हु कुड डू दिस ऑटोमेटेड चिप फ्लोर प्लानिंग, राइट? बेसिकली तो उसमें हमें लोग चाहिए हु नो software very well, who know machine learning, and they want to learn APR या auto place and route. क्योंकि आजकल होता ही है कि यूजुअली एक चिप में बहुत सारे डिफरेंट ब्लॉक्स होते हैं, वो ब्लॉक्स वो ऑटो प्लेस करते हैं, राइट? उस ऑटो प्लेस को आपको पहले लर्न करना पड़ेगा, एंड देन यू विल हैव टू गो थ्रू दिस पेपर एंड देन यू विल ट्राई टू इम्प्लीमेंट दिस. दैट कुड बी एन FIP. इस तरह के there are other lot of FIPs around software automation of the chip design process. फिर ये हो सकता है जैसे कि अलीजान वगैरह काम कर रहे हैं, दे हैव डिजाइंड देयर ओन फ्लोटिंग प्रोसेसर, राइट? फ्लोटिंग पॉइंट यूनिट. we can take that, उसको हमने MPW-6 में tape out किया है. Somebody can come up with something जैसे ये something in power control, some function, you can design that and tape it out, right? So different things can be done. So it depends. There are a lot of project ideas that we have. When project ideas, there are a lot of things that can be done. And most are obviously related with software and IC design to work around it. Does that make sense?
What about security? जब हम बात करते हैं open source की, so there is a huge concern regarding security when it comes to RISC-V or any other process.
Yes.
क्योंकि हर कोई contribute कर रहा होता है.
Yes.
So although but अगर हम बात करें military grade applications भी, तो उसमें I think it's much more less secure than.
No, I think that's a great question, right? I think fundamentally something being open source does not make it more unsecure, right? क्योंकि अगर if something is, let's say आपके पास एक code है, आपने एक code था जो कि does something, right? It does whatever, it paints this wall, right? If I get that code and then I have the code and I can then paint my own wall with that code, right? It doesn't make the code unsecure, right? The code could be fundamentally insecure because somebody could hack it, right? That would be the fundamental thing in this code. That fundamental insecurity जो बात कर रहे हैं, we are also doing research on hardware security in NAD. We have a project going on, right? We have an expert from Cisco who's leading that project. But the other idea that I didn't mention कि हम MERL के through ये करना चाह रहे हैं कि it's not about me only, right? क्या I'm the only. हमारा model ये है कि हम जो experts हैं USA में जो who are ready to contribute, और बहुत सारे लोग हैं ऐसे, I mean, who know who are much more expert in the many different areas than me. For example, Dr. Ali Shujar, right? He's in Cisco, so he's leading a little FIP in hardware security, right? So hardware security is very important. How do we implement hardware security in RISC-V? So इसी तरह you can come up with an idea and then I can poll in the US and say, look, is there a person that I can pair up with you, right? So वो person would be at the leading edge of the technology, and he will try to work with you and train you that area. Similarly, हम लोग एक PLL कर रहे हैं, phase block loop. उसमें मेरे एक और दोस्त है आमिर बशीर. He has like, I don't know, 31-32 years of experience at Intel. He is leading that project. There are 9 people from NAD. उनका FIP कर रहे हैं, right? So that's the other idea हम promote कर रहे हैं. A connection of the students from here through their FIPs to international experts in the specific domains that you are interested in, right? That's another opportunity. ठीक है? Thank you so much.
Thank you very much, sir. Thank you, Dr. Rumi Naqvi, for giving a wonderful and a very engaging talk on the wonderful work that MERL is doing, and for stressing the importance of Pakistan participating in IC designing and getting its due share in the IC designing market, because that is where the future lies. I would now take this opportunity to invite Pro Vice Chancellor DHS Sufa University, Professor Dr. Ahmad Said Minhas, to say a few concluding remarks before we proceed towards the cake cutting ceremony. Sir.
Bismillahirrahmanirrahim. Assalamu alaikum. Dr. Rumi, faculty members of the EE students, participants, Assalamu alaikum and very good afternoon. It is afternoon now. Just wanted to say thanks to Dr. Rumi साहब के वो तशरीफ़ लाए और आपके साथ उन्होंने जो प्रोजेक्ट वो अमेरिका में आप कर रहे हैं और अपने इंटेल के साथ जो काम कर रहे हैं, he shared his experience with you. It was quite instrumental, especially I was talking to the Rumi साहब के our kids in the EE department have like little concerns about their future. So when I was young, though I still feel young, in NAD the best technology used to be EE. Okay, but I'm talking about like 30 years back, followed by the computer science. Unfortunately, I don't know what happened. I thought that perhaps we are bad at teaching and the students are not happy. तो मैं मुख्तलिफ टीचर से पूछता रहूँ कि कैसे कोई मसला तो नहीं हो रहा, कहाँ गैप किधर आ रहा. But when I did the analysis in overall terms with regard to the Pakistan. To my surprise that this is happening with EE everywhere. लेकिन ये परसेप्शन एक तो भेड़ चाल की सूरत में जारी हो गई. Otherwise, I don't find whosoever EE graduate or the alumni to whom I meet my office, which has an open door policy for all, and especially my students. When the students come, I even don't talk to the faculty members. They are like my assets. मेरे अपने बच्चे. मैंने EE वालों को कभी जॉब के बगैर नहीं देखा. They all are very well settled. चंद एक हैं जो अपने प्रोजेक्ट कर रहे हैं तो उसमें थोड़ा स्ट्रगल कर रहे हैं और ऊपर चढ़ने की कोशिश कर रहे हैं. बी रेस्ट श्योर कि EE के साथ कोई इशू नहीं है. टिल द टाइम यू डोंट मेंटल मोबिलिटी इधर नहीं लेकर आओगे तब तक एक वो सब में से वो पेसिमिस्ट काइंड ऑफ अप्रोच रखोगे तो प्रॉब्लम होगी. You made an excellent choice, but as Rumi Sahab also must have said that if it is blended with the computer side, which is like now in the market, इसका चल रहा है ज़्यादा, उसकी चल रहा कब तक चलेगा तो उसके जो एनालिसिस करते हैं एनालिटिक्स बोलते हैं कि another 5 to 10 years इसकी उठान है, उसके बाद इसने फिर अपने नेचुरल कर्व में नीचे आना. Though I don't say wrong about my CS students also, they are also my sons and daughters. बट फॉर यू ऑल्सो फ्लक्चुएट करता रहता है मार्केट की डिमांड के हिसाब से. तो अगर उसको कंप्यूटर के साथ कोई ब्लेंड करना चाहें, कोई अपनी स्किल्स को बढ़ाना चाहें, स्पेशली दो स्टूडेंट्स हु आर इन 5th, 6th, 7th and 8th semesters, I'll ask request the HOD also और रूमी साहब से भी आप इससे मशवरा लीजिए कि आपको हम कौन से ऐसे इलेक्टिव ऑफ़र करें. ये आपका काम है कि मार्केट से आप बच्चों ज़्यादा इनसे तगड़े हो, हम तो पुराने हो चुके. हमारी मेंटल मोबिलिटी वो नहीं रही. हम जंग में जब भी जाते हैं, व्हेन आई वाज फाइटिंग इन स्वात और वज़ीरिस्तान फॉर दैट मैटर इनिशियली इन कारगिल, वहाँ पे कप्तान ज़्यादा क्यों शहीद होते हैं, लेफ्टिनेंट कैप्टन्स, बिकॉज दे डोंट केयर. वो हमसे ज़्यादा मोटिवेटेड हैं, हमसे ज़्यादा. द मोमेंट मोर यू ग्रो इन एज उतने ही आपके रिफ्लेक्सेस स्लो हो जाते हैं. आई एम नॉट टॉकिंग अबाउट यू सर, बट इट इज़ राइट सर. जब मैं अल्लाह अकबर बोलता था और नारा लगाता था, मेरा भी अकबर के पीछे नारा तकबीर और अल्लाह अकबर पूरा नहीं होता था, तो मेरे कैप्टन जो हैं वो आगे निकल चुके होते थे और उसमें से 2-3 गिर चुके होते थे. तो इसलिए मैं कह रहा हूँ कि यंगस्टर्स जो है ना, ये बहुत डायनेमिक हैं. दे हैव सच अ ट्रेमेंडस काइंड ऑफ अप्रोच टू द थिंग्स. तो आप जो पढ़ना चाहते हैं, इनके वाइल्ड आइडियाज़ पॉलिश आप लोगों ने करने. आप वो कोर्सेज इलेक्टिव्स इनको ऑफर करें. डोंट गो फॉर द स्टीरियो काइंड ऑफ थिंग. एंड स्टिल इफ यू थिंक कि यार बोला था कुछ हुआ नहीं, PVC बोल के चला गया. आई हैव एन ओपन डोर पॉलिसी. जस्ट एंटर टू माय ऑफिस एंड आस्क मी कि वी आर 10, 12, 15. ऑफ कोर्स इट शुड बी लाइक नॉट इंडिविजुअली नहीं हो सकेगा. आप आएँ और बताएं जो EE के स्टूडेंट्स को चाहिए होगा, आई विल प्रेजेंट यू राइट. लेकिन आपकी स्किल्स हमने डेवलप करनी. इस परसेप्शन को हमने निकालना है कि EE इज़ लाइक नो मोर अट्रैक्टिव फील्ड इन द इंजीनियरिंग साइड. यू हैव एन EE क्वालिफाइड फ्रॉम ND सिटिंग विद दिस एज और इतने एक्सपीरियंस के साथ, ही इज़ रूलिंग. एंड दैट व्हाट ही सेड दैट मैं आई एम लुकिंग फॉर अ ब्लेंडेड काइंड ऑफ या डुअल काइंड ऑफ. उसमें IC के हिसाब से भी देख रहे हैं, बट यू डोंट फाइंड दैट काइंड ऑफ स्किल. तो सर वो इसमें जो आप हमें जो मशवरा देंगे हमारे बच्चों की बेहतरी के लिए, विल डू दैट. आप कोई रिसोर्स पर्सन ऐसा कि इससे प्रभाव, तो मैं इंटेल में उसको कहूँगा कि आ जाओ, अगर तुम मुझसे पढ़ के आए हो, मुझे रिसोर्स का ही बताइए. वट एवर ही चार्जेस आई विल गिव हिम. इफ़ यू थिंक देयर समबडी देयर जहाँ पे आप माशाल्लाह से काम कर रहे हैं और वो ऑनलाइन इनको पढ़ा सकता है, आई एम रेडी टू पे हिम इन डॉलर्स वट एवर. लेकिन माई किड शुड मीट योर रिक्वायरमेंट, स्पेशली EE. अगर EE के बच्चों को मैं प्लेसमेंट इंशाल्लाह 100% कोशिश करेंगे. लेकिन सिर्फ ये ख्वाहिश से नहीं होगा, बच्चों आपको मेहनत भी उतनी करनी होगी. ठीक है, मिडनाइट ऑयल के कनस्तर जो रखे होते हैं हमने बेड के पीछे और हाथ में व्हाट्सएप होता है, उससे मिडनाइट ऑयल को बर्न करना पड़ेगा. इक्वली यू हैव टू रिस्पॉन्ड. लेकिन आपको यूनिवर्सिटी की तरफ से कोई कमी जो है महसूस नहीं होगी. तो आई विश यू ऑल द बेस्ट. सीइंग एवरीबडी सिटिंग हियर एंड लिसनिंग टू दी, विच इज़ एन ऑनर ऑफ कोर्स, listening to a person like of his stature would really be beneficial. So sir, I would be looking for your kind guidance. You'll find us trying to match your steps. Thank you very much. God bless you.
Sir, I would also request, taking this opportunity, sir, I would request the PVC to present a shield as a memento to Dr. Rumi. Thank you very much, sir. Thank you, sir.
Students, thank you for your presence. अभी टेक्निकल सेमिनार हमारा स्टार्ट हो रहा है. अगर आप में से किसी को टेक्निकल सेमिनार में पार्ट लेना है, you can take part in the seminar. Otherwise